Hi kids, welcome to Mr. Roche's Do-It-Yourself Molarity Lab. Do-It-Yourself Molarity Lab? Mr. Roche, I don't have a lab. Yes you do. You are going to need for this Do-It-Yourself lab some drink mix. My daughter likes lemonade, so I purchased lemonade. I would have been better off getting Kool-Aid, which would have shown it a little more, but then who would drink it? So you can get Kool-Aid or iced tea or lemonade or whatever powdered drink. We're looking for powdered. And a flavor enhancer. Either a cup from your house, because look, on the other side of the cups, metric, milliliters. That'll be good. Or you just need something like this. A teaspoon measured from a nice teaspoon. Don't get one of these. These are no good. What you want is one of these. You want one of these nice measury teaspoons. You can get a quarter teaspoon, you can get a half teaspoon, you can get a full teaspoon. You can get a tablespoon. Don't get a tablespoon. By the way, shout out to COVID for the hairstyle. Turns out, when I don't get a haircut for a while, I start looking like Wolverine.
Hey, look at him. Big old ass coming out the front of his shirt.
I know you don't have a scale at home, so we'll use my scale. Watch what happens when I take a half teaspoon, you have one of these, ask your parents, and level it and put it in this cup. It's exactly 2.0 grams. What? You're welcome, science. So 2.0 grams for every half teaspoon. But Mr. Roche, I only have a full teaspoon. Well then, if you use a full teaspoon, level it off, it would be 4.0 grams. If you only have a quarter teaspoon, it would be 1.0 grams. I got it covered, kid. We know for every half teaspoon, you have 2 grams of solid. All right, so we are gonna put that 2 grams into liquid. Now again, you're gonna say, Mr. Roche, I don't have one of these. No, you don't. I certainly don't have one of these or one of these. Humble brag. But what you do have is one of these. And while you use only this side because we live in America, turn it around and it tells you milliliters. Look at that. If you use a whole cup, use 237 milliliters. If you're going to use half a cup, let the internet tell you it's 118 milliliters. So just do it that way and you should be able to have whatever your volume is. And you can use whatever cup you want. You can use a Dixie cup. You can use one of these. I've already marked a line where 100 milliliters is on a cup like this. Solo cup, red Solo cup, all good. So here I have my 100 milliliters filled up to that line of water. I'm going to then put my 2 grams of pink lemonade in there. And let's discuss what type of solution I've made. As you can see, when it's dissolved, that's drinkable. Lemonade. Old socks, is there anything they can't do? All right, we have 2.0 grams. I'm gonna go with, assume that's 100% sugar. Sugar, as you may recall, is C6H12O6. Shout out to the biology people for teaching you that. So therefore, the mass of this would be carbon, there's 6 of them, each carbon on the periodic table weighs 12. Hydrogen, there's 12 of them, each hydrogen on the periodic table weighs 1. Oxygen, there's 6 of them, oxygen on the periodic table weighs 16. I know it's 180 just because I looked in advance. So it's 180 grams. So if we have 2 grams, if we have 2 grams, and each 180 grams is 1 mole, we will get how many moles that is. 2 over 180, or 1 over 90. That's math. 2 divided by 180 is 0.011 moles. 2 grams is 0.011 moles. Now, I can erase this because it's on video. You can record it. Love that sound. How do you make a chalkboard sound with a whiteboard? we need to divide that by how many liters. As I told you, this is 100 milliliters. And hopefully we all know how to make 100 milliliters into liters by moving that decimal 3 places. 1, 2, 3. So that's 0.1 liters. So 0.011 divided by 0.1, what I have made basically is, divided by 0.1, a 0.11. Could have done that in my head, I guess. 0.11 molar solution. Now I'll taste it. Yuck. Tastes like water. Side. So what do I need to do if it tastes like water? Put more of this or less of this? You think about that, kids. Alright, so the answer will be I need more of this. So next time I'll try 2 grams. Maybe I'll try 6 grams. If I'm in a really excited sugar mood, maybe I'll go to 10 grams. Just keep doing it. Figure out your molarity. Let me know what your favorite molarity was. How's that sound? That is step 1, using grams to get to molarity. Now let's do step 2, using a pre-concentrated solution to get molarity. So now, step 2, what if it's already concentrated, Mr. Roche? Great question. Let's talk about that. When you use a very concentrated solution, we use a different equation. It is M1V1 equals M2V2.
Which is to say, the molarity of the concentrated solution times the volume of the concentrated solution will equal the molarity of the dilute solution times the volume of the dilute solution.
And this is true because basically, if I put some of this into a cup, I'm putting a certain number of moles in there. And that moles isn't going to change whether I dilute it with water here, or don't put any water in there. It's going to be the same moles of water, or the same moles of flavoring, because of what I put in there. So this is saying is moles over liters times liters equals moles over liters times liters. So moles equals moles. As long as I don't add any more of this in between the start and finish, then it's the same number of moles that's in there. Let's talk about how that's going to work with this specifically. The molarity of this, I did this on my own, is 0.4 molar. That's going to be true for almost anything you buy. This is sugar-free. There's no sugar in here. It's 100% water and citric acid. Look at the ingredients. That's what it'll tell you. Actually, there's other things in there. But basically, it's citric acid and water. So, it's 0.4 molar citric acid. Citric acid's what's bringing the flavor. If you use this one, or the blue one, or you like, I don't know, another one.
Squirt, 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 squirt. Parkour squirt. Synchronized squirt.
Pretty much citric acid. So, here's the problem again. You're going to say, Mr. Roche, I don't know how much I'm adding of this. How many liters am I adding? Well, again, guess what, kids? The liters you're adding can be done with one of these. So just grab one of these from your house. I'm going to this is going to require, here, this is going to be hard. I know this, but watch. You're going to, because it comes out really hard. Oh, look, I'm doing it right. All right, so I'm going to put a whole half teaspoon in there. All right, so again, you're going to want to use Google. 1 teaspoon is 4.92 milliliters. I'm using half a teaspoon, so we're going to go 2.46 milliliters for that. I know the concentration is 0.4 molar, and I know the liters is whatever I just found out. 2.46 milliliters. 100 milliliter line. So let's get back to our math. So 0.4 times 2.46 will equal the new molarity, what is that, times 100 milliliters, which is where I filled up my treatment line. Filled that up to 100 milliliters. So, to figure out what the molarity of my new solution is, I will just multiply 0.4 times 2.46, and that will equal my new molarity times 100. Now I know what you're saying. Mr. Roche, you said that was liters and now you're using milliliters. What the what, Mr. Roche? Well, you can always go to liters. We talked about that in gases. However, since milliliters is on both sides, not very well indicated, they cancel, so it doesn't matter. Molarity will equal molarity. Thanks, math. Right, 0.4 times 2.46. 2.46 is 0.984. So 0.984 equals 100 m. And then just divide 100 by both sides. M is going to equal, divided by 100 goes that way, right? 0.00984 molarity. So, this is 0.00984 molarity. Let's take a taste of that. Little strong. So, I even want to get more dilute than point for my personal taste. And I'll do it again. This time, what would I do? If it's too strong, I need more water or less Kool-Aid stuff. That's the lab. It should be fun. I hope it's fun.